Welcome to this tutorial video, and today we'll be solving a question from the tutorial sheet on static equilibrium. Yes, and in this question we are told to say the system has no friction, and that means the tension in the cords is not affected, is not changed in short, and we're asked to find the value of W3 and W2. So the weight W1 has been given, and that is 800 newtons. So if the system is frictionless, the value of T1 is equal to W1, and the value of T2 will be equal to W2 in this case. And for us to get W2, the value of T2 will be equal to W3, and the value of W2 will be given by the addition of T1 and T2. Okay, so you guys can pause the video and try this question on your own. Okay, so one of the conditions of equilibrium, static equilibrium, is that the summation of forces should be equal to 0, both in the x and in the y-axis. And in this question, you notice to say we have summation of forces. We can consider summation of forces in both the x-axis and the y-axis. And since the pulley is frictionless, meaning to say the weight W1 will be equals to T1, and that would be equals to 800 newtons. So the value of T1 is simply 800 newtons because the tension in the cord is not affected, is not changed. Then for us to find the value of T2, we'll consider summation of forces, summation of forces in the x-axis. That will be equals to negative T1 sine 40 plus T2 sine 50, and the summation of these forces should equal 0. Now manipulating this equation for us to find T2, you should get T2, in this case, making T2 subject to the formula, will give us T1 sine 40, that will be divided by sine 50. We already have the value of T1, and that is 800 newtons, multiplied by sine 40 and divided by sine 50, and this will give us the value of T2. As earlier said, the value of T2 will be equals to the weight W3, because in this case the system has no friction. So the value of T2 will be 671.3 newtons, which will be equals to W3. So we have found the value of W3, and that is equals to the value of T2, which is 671.3 newtons. Now we go to the second part of the question. We have to find the value of W2, and for us to find the value of W2, this will be given by the summation of forces in the y-axis, which should also equal 0. So this will be given by T1 cos 40, which will be added to T2, because these two forces are the one that are supporting the weight W2, and that will be cos 50, and that will be equal to W2, because the two forces are supporting the weight W2. Alright, so we can replace the values. We already have the value of T1 and T2, so that will be 800 cos 40 plus 671.3 cos 50, and the addition of this should give us W2, and W2 will simply be 1044.3 newtons. So we have found the value of W2 to 671.3. W1 was simply equal to T1, which was 800 newtons, and W2 is 1044.3 newtons. So you guys, you can leave your comments in the chat section, and you can share your views on this question. So in the next video, we'll be considering question 7 in the tutorial sheet, which is this question there. You can try it on your own. you see how best you can solve the question, and we'll see the solutions in the next video.